Hi everyone, my name is Ziwei Liu, and today I'm gonna present you the car insurance Coco project. First of all, let's have a look at the overview. So, first part is gonna be business objective, the EDA, data cleaning, modeling approach, model comparisons, hyperparameter tuning, and finally we'll reach to the final model. So, for our business objective, we can clearly conclude that to be a predictive model that can accurately identify potential customers who are likely to purchase car insurance via telemarketing calls, enabling the banks to prioritize high conversion leads, optimizing call strategies, reduce campaign costs, and improve overall marketing efficiencies. So first, we begin with the EDA. In here, I plotted the age distributions. We can see that since the majority of the potential customers are between 25 and 45, customers' campaigns for car insurance may be more effective to tailor to the young to middle-aged populations. Moving next, I then to put up a balanced distributions against each individual's balance. In this implication, we can see that since most customers have modest balance, targeting high balance customer with premium insurance package could be more efficient. However, large base of low balance users could still representing a valuable market for basic coverage or installment-based offering. And moving to the third graph, which is bar chart representing the car insurance subscription counts. And in here, the inside, we can see that the bar for non-subscribers is taller than the subscribers. This means that more people declined the offer than accepted it. Based on the visual estimation, the subscriptions rates appears to be roughly 40% or less. So in here, I did a descriptive statistic summary. We can see that the average customer is 41 years old with the age ranging from 18 to 95. Balance shows a very high variability, indicating a skew distribution, some extreme values. Most customers have 1 to 2 contacts and no prior attempts. A large portion of day past values are -1, implying no previous campaign contacted. About 40% of customers subscribed to car insurance in this case. And here I also did a correlation heat map, which representing the numeric feature and car insurance are generally weak, but a few stand out. Things like previous attempts and they pass show positive but modest association with the purchase decisions. And number of contacts show a slightly negative relationship, which could indicating a contact fatigue. Through no features has a strong linear correlation. This small signal may be valuable in predictive modeling, especially when combined. Since previously we did investigated the car insurance purchase rates by age. Now I did a bar chart for car insurance rates by jobs. We can clearly see that the highest purchase rate are observed among students and retired individuals, possibly due to their availability and representative responsiveness to marketing efforts. Conversely, entrepreneurs, blue-collar workers and service employees show lower conversion rates potentially due to differing financial priorities or time constraints. This insight can be guided targeted campaign design and ensuring resources are allocated more effectively. In here, we more specifically dive into the age group by the purchase rates. We can see that the youngest age group and the lowest age group exhibit notably higher subscription rates than the middle age segment. This pattern can suggest that younger individual may be entering financial independence and older individuals may be more risk averse. So since we've done all the previous job, now we headed to the data preparation and data cleaning. In this case, I've cleaned the missing and irrelevant values, and also to create a more numeric representations for the model, I created a new feature which is called duration created by chord n minus chord starts. And I also encoded categorical variables and split into data and training training and testing data sets to for the later purposes. So in here, for the modeling approach, first begin with XGBoost. So in here, I've put up a bar chart for showing the top 10 feature importance, extracted top 10 features based on model's feature importance, exclude irrelevant features like communication, household insurance, and eventually I visualize the data results by using a bar charts. So our goal in here is to predict the model who are more likely to buy a car insurance. So in here, I use XGBoost classifier with log loss evaluations. And here, I previously mentioned that we use 80% training data and 20% testing data. And also, we have concluded with some numeric figures results by showing the accuracy F1 score and classification reports. Secondly, in this case, in order to compare with the previous modeling approach, I've been selecting the random forest approach to do the same thing, to extract top 10 features based on model's features importance. And also, like the previous one, we excluded irrelevant features like communication, household insurance. And here, basically the same by fitted this data into the same 20/80 splits as XGBoost. We also put up and find out the accuracy F1 score and classification reports. So next step is model comparison and selections. In this case, we conclude that we're gonna use a random forest model because our goal is to accurately identify potential car insurance buyers. In this case, missing a likely buyer for false negative is more costly than mistakenly targeting a non-buyer because random forest model gives us a high recall on buyers, meaning you caught more actual purchases than XGBoost. That's the reason why we choose random forest model. So in this case, in order to fine-tune our model, I've been using hyperparameter tuning in this case. So there are several parameters that we are considering in this case. First is the estimated number of the trees in the forest, and maximum depth of each tree, minimum sample required, and minimum sample required at the leaf nodes. Our tuning approach is using the grid search CV, randomized search CV for cross-validation tuning. We eventually, by evaluating based on the F1 score to prioritize the recall of the buyer, we can see that from the previous baseline validation, the accuracy has increased, and also the F1 score. And most importantly, we have increased the record in this case. By using a hyperparameter for random forest model, which reduce overfitting, improve generalizations, and further boosted recall for class 1, which is the target buyers. Thanks for joining this presentation. If you have any questions, you can ask me now. Thank you.